One of the areas where the ability to count number of outcomes is particularly important is in the area of cybersecurity and passwords. So let's think about some common types of passwords. Many times people use 4-digit passwords, usually known as PIN numbers, personal identification numbers. So let's think about how many different possible personal identification numbers are possible if every digit can be repeated. So there are 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to make 4 blank spaces to represent the 4 numbers, the 4 digits in my PIN number. There are 10 possible digits for each spot. So I could have everything from 0, 0, 0, 0 to 9, 9, 9, 9 and everything in between. Now, according to the fundamental counting principle, if we think about these numbers that I'm choosing or putting in my passwords as events occurring in sequence, then we're just going to multiply the number of outcomes for each digit for the total number of outcomes for a 4-digit number. And so we would have 10,000 different PIN numbers possible. Now, interestingly, not all of those numbers are equally likely to be chosen. There are quite a few people who will pick a number like 1111 or 1234 or 8888 or 8558 or things with a pattern. They'll pick something like that. And so a lot of times if a person were trying to guess someone's PIN number, they could guess one of those really simple ones and they might guess it. So it's not good to pick an obvious one. Another thing people do a lot with these PIN numbers is they use their birthday. But you'll, as we will see soon, that's not a good idea either. So let's say if we used birthdays. Let's think how many different possible numbers are there if we use birth dates. And so, for example, my birthday is 12/02, December 2nd. So let's think about this first digit. How many different possible digits are there if this first 2 digits represent a month of the year? Well, the only thing I could use for this first digit is 0 or 1, because my month number either has to start with a 0 or 1. So there's only 2 possible first numbers to use if you're using birthdays, and that's represents the month. Now I could have anywhere from 0 to 9 for my second digit, because I could have month 01, 02, 03, 04, all the way up to 11, 12, and so forth. So there could be 10 possible digits for my second number. Now the third digit here, this represents the date. Well, what's the biggest day of the year that I can have? 31. So the third number can't be any bigger than 3. So there's only 4 possible numbers, 0 through 3 for this digit. The fourth number could be any of 9, because I can have dates that would have a second digit of anywhere from 0 to 9. I could have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19th of the month, so forth. So this could be all 10 digits. Now, if you are thinking, well, hang on, this is not exactly right because, for example, I couldn't have day number 39, so there's not really 40 different days of the month I could pick, and you are correct. There aren't 40 different. So this is a little bit simplified version. I could put 0 with any one of 10 digits. I could put 1 with any one of 10 digits. I could put 2 with any one of 10 digits, but 3 could only go with 0 or 1. So technically, no, there aren't quite this many possible days here. Same thing here. 0 could go with anywhere from 0 could go anywhere from 1 to 9, but 2 could only go with 1 could only go with 1, 1 or 1, 2 for month 11 and month 12. So this is really more than there are possible PIN numbers for birthdays, but even this is only 800 numbers. So I'm going to put actually a bit less if you think about what I just told you. So there are not very many possibilities if you choose your birthday. So is it a smart idea to choose your birthday? No, someone could guess your PIN number a lot faster with only 800 possibilities to try instead of 10,000. So what do most websites do? They give you some very specific instructions about how you have to pick your password so that you have a more secure number. So let's say a website has this requirement. You have to have at least 5 characters rather than 4 spaces, 5 characters, at least one number, at least one capital letter, and at least one of these 4 special symbols. I've simplified it. A lot of times passwords are even longer than that. They'll say 8 digits and they'll give you more possible special symbols, for example. Now, if you're like me, I've had passwords I've used in the past, and then I get a message from my website that says you need to update your password. So what do? I'll just capitalize the first letter and add an exclamation point at the end, which is kind of a lazy way to do an extra password because apparently a lot of people do that. So let's say that in my particular password here, that's 5 characters long, I'm going to use a capital letter for my first digit. So for my first digit, I have 26 different possible capital letters. The last character, so I'm going to put in my 3 middle ones, the last character is one of the special symbols. So there's only 4 possibilities for the last character. And the 3 in the middle are all numbers or lowercase letters. Well, there are 10 numbers plus 36 lowercase or 26 lowercase letters, so 36 possible symbols I could use for the 3 middle numbers. So if I multiply all these together, I would have, using the criteria that I just said, if this is the way I decided to make my password, that would be the possible number of passwords. Now, of course, a lot of people want to put in words here that they can remember, so that would even reduce further the possibilities. But let's say that we're just kind of doing random passwords. This would be the number of passwords, and I'm going to go show you on the calculator. I multiplied all these 3 together, and this is what I got. I got 4,852,224. So that's a lot of possibilities. We're a lot more happy with that than 800 possibilities. So 4,852,224 possible passwords. Now, let's say instead of being this lazy person that said, let's just capitalize the first letter and change the last letter to a symbol, let's say that I truly used any possible combination of letters and symbols. So I have 26 capital letters, I have 26 lowercase letters, there are 10 numbers, and there are 4 symbols. So if I add those together, that is 66 possibilities. So 66 possible characters. And I'm going to make a 5-digit password, and each one of those spaces could contain a possible 66. There would be 66 different possibilities for each of those. And I'm going to multiply those together. So basically I'm just doing 66 to the 5th power. Let's find out how many more passwords are available if we have 66 possibilities for each of the characters rather than what I had in the previous example. So if I do 66 to the 5th, you'll see that that is significantly more. I'm up to over 1 billion types of different passwords. So this turns out to be 1,252,332,576 possible passwords. I'm feeling a little more secure now. Now, let's say that a hacker was trying to guess your password, and they were just guessing, they were just trying all possible combinations of numbers. They programmed their computer to do this, and let's say they could program their computer to try 10 passwords a second. Okay, so they were just typing in password after password after password, 10 a second, and 1 every 6 seconds. We're just putting them in, trying them out. Let's see how long it would take to break your password. So let's say you did the birthday password. Let's say you just did the 4-digit birthday. 4-digit. How long would it take to break the code? You have 800 different possibilities. They're doing 10 per second, so it would just take 80 seconds for them to guess your password. Not very long. That's not terribly secure. Let's say we did the 5-digit example 1. So in the 5-digit example 1 case, then you're going to have 4,852,224 divided by 10. I'm going to do a little stuff on the calculator. Now, obviously, if I just divide this by 10, I'm just moving the decimal place over 1. But that's a lot of seconds, so I'm going to put this into hours, minutes, and hours, and so forth. So let's put in this number that this top number here. And I'm going to divide it by 10, first of all. And I get 485,222 seconds. Now let's divide that by 60 again, and this would tell me how many minutes it would take. Okay, oops. So that would be how many minutes. So let's divide it by 60 again, and this would tell me how many hours it would take. There's how many hours it would take to break the password. Let's divide this by 24 and figure out how many days it would take. So it would take about 5.6 days of continually trying password combinations to guess your password. Now, probably for you, so this would be seconds, which is equal to about 5.6 days. Probably nobody's going to bother that for your bank account. They might bother doing that for someone very wealthy. It would be worth their while to spend 5.6 days guessing their password. But and it's still a little scary. That's not too long it would take. So let's look at the 5-digit example 2. So if we look at the 5-digit example 2, that was the one that was 1,252,332,576. If we divide that by 10, that would be how many seconds it would take. So let's put that into days. All right, so see how long this would take. So I'm going to go up to my previous number here, this one. Okay, and let's divide this by 10. Okay, so that's how many seconds it would take. So now let's divide it by 60 minutes, divide it by 60 hours, divided by 60, oh no, divided by 24 now. Divided by 24 days. Oh, let's go to years. Let's divide it by 365. 3.97 years of continually trying numbers before they could break that password. Wow, that's a lot more secure. This turns out to be 3.97 years. Okay, so, and that's just a 5-digit password with 66 possible characters. What if you had an 8-digit password and you added more special symbols? It's going to even take longer. It's going to take significantly longer. So that's why long, complicated passwords are really more secure. That's why so many websites, and especially ones dealing with money, will ask you to do what's called a 2-step verification, where you'll put in your password, and then after you put in your password, they'll send you a code like on your cell phone, and then you have to type in this randomly generated code to access your account. So the more layers of security, the better. So don't pick easy to guess, simple passwords. Make your passwords hard to break.